Hello YouTube, and sorry for not uploading any videos for a pretty long time. I was a little busy and in my university, and even this video was shot from my university dorm room, so sorry for this lighting condition. You know the cases, and sorry for my voice. I have a little cold, so sorry for that. So let us begin. Today's topic is substitution type reactions, and there are three types of substitution type reaction: SN1, SN2 and SNI. Today's discussion will be primarily focused on SN1, and in some new videos that I will post, I don't know the time exactly, but I will post them as soon as possible. SN2 and SNI will be denoted. Nucleophilic substitution reaction involves removal of one nucleophile and replacement of the nucleophile with another new one. This is basic level chemistry, but the problem is not with identifying SN1, SN2 or SNI. The problem is if questions are asked from a given reaction that whether it is an SNI or an SN2, or find the rate based on those ideas, then the problem arises. That's the reason why I have divided the video into three categories, and three separate videos dealing with each of these reactions will be uploaded. What is SN1 type reaction? SN1 full form is nucleophilic substitution type molecularity 1. That means that in the rate determining step, the number of molecules present will always be 1. There will be one interaction with the primary molecule, and we will see that in a bit of an example. Let's move on. What are nucleophiles? Well, we all know what nucleophiles are, but still let us refresh our memories one more time. Nucleophiles are like rich people in our world. They basically have lots of money, so they don't need money, and they basically hate that. So nucleophiles have lots of electrons and they don't need electrons, so they want to hate, give it away, charity, And electrophiles are like the poor people. They don't have money, so they always try to have some money by any means, working double shift maybe. So they will always try to accept those charity facts. Let's focus on with a real life example, with a reaction obviously. So in this example we can see that this is basically a second degree carbon attached with C2H5, CH3 and a bromine. This is an alkyl halide. We treat it with an aqueous KOH and we get corresponding alcohol plus HBr. Now generally whenever in high schools or in middle schools we are taught this, they generally say this OH will go here, this Br will come out. Sorry, this is actually my hand just shook when I was drawing. So this OH will directly, they say that the OH will go and attack this one, this will go out and you get this and this. This is wrong. This is not how the reaction actually proceeds. Whenever we give base, we always forgot one very important thing, and that is H plus. That H plus is also there. Base does not mean that there are no proton available. Base means there are proton available also. And even this representation actually in scientific point of view is wrong, because even though OH minus and H plus are being dissociated, they are still in attractiveness to each other until and unless new bonds are being formed. Now anyhow, but the correct representation should be like this. The first step is formation of this carbocation. This is a second degree carbocation. So first let's form the carbocation. Bromine atom will move H plus towards H plus, thereby forming HBr and this carbocation. Once this carbocation is formed, OH minus can attack, thereby forming corresponding alcohol. One thing we should always remember in this particular case, there is no change in the stereochemistry. Stereochemistry remains as it is. So if it is an R, it will remain as an R. If it is an S, it will remain as an S. For those of you who are not so familiar with stereochemistry, we will make a new sessions over stereochemistry in an upcoming video. So to sum it up, you are required to understand three important things. Whether a stable carbocation can form. If the answer is yes, try to think about SN1. Next, if any information regarding the rate is mentioned, see if the rate is a very fast reaction. Then you may presume that it is SN1. Last but not the least, you will always see the stereochemistry. If there is no alternation in the stereochemistry, yet a substitution is taking place, think about, and obviously if there is no radical exchange mechanism involved, it may go through SN1. However, always keep in mind that the substitution size also matter. If it is a phenyl compound, then how the reaction will occur little bit different. But that one we will discuss later on after we have completed our other two, SN2 and SN1. So there we go. The video is almost complete. Now, since the video was made within a very short span of time and the lighting condition is also not so good, I hope I can make it a little bit better, because the idea of this video and the other two videos will be to clear the basic concept of SN1, SN2 and SNI. In the later on sessions we will discuss with real examples where we will increase the substitution size and many other ways by which different types of questions comes. For a basic understanding, I will always refer that you go study some books. There are excellent books available. I always personally like Claydon. It's a wonderful book by Oxford University Press. A little bit costly, but believe me, if you like to study, that book is worth having. It's like a treasure. I always say it is one of the Bible book for organic chemistry. So there you go. If you have any doubt, please be polite. Don't take out your anger on the comment section. And if you just sound anger, does not mean that people are going to frighten from you. You are just becoming a troll basically. So don't become a troll and post heinous comments, because most of those comments will be deleted, believe me. So be gentle, and if you have any question, I will be there to solve as I can. And if I have made any mistake, please point it out, because I always love to learn. And thank you, that's it, and I have to go now. I have class also, so see you soon. And do like, subscribe and share it as much as you can. Thank you, have a nice day.